we want to talk about the circular shift register. So if we want to actually be more specific, so we want to design one shift left register with rotation. So what it means, again, we are looking for 4-bit shift register. So you have actually 4-bit. So if I change the color, so that's clear. It should be shift left, right? So that means whatever you have here, it should be moved to this. Whatever you have here, it should be moved here. Whatever you have here, it should be moved to here. But whatever you have in the actually as the bit that you have on the left side is not going to be lose its value. It's actually value back to the right side of your shift register. Okay, so that's what we call say that's actually is a shift left, but it's with the rotation. You are not losing whatever you have in the left side of your shift register. So let's see how we could design that. So that actually is exactly similar with the other design that we had for shift register. So definitely you use actually for D flip-flop. So we just put 4D flip-flop here. Because we want to design 4-bit shift register. So this is D flip-flop. This is D flip-flop. This is a D flip-flop. And this is D flip-flop. Okay. So let's see what we need to do. So first, start with the most simple part. So all of these D that we have is a D flip-flop with sensitive to the rising edge. So just put this symbol here, which shows these are sensitive flip-flop to the rising edge. So similar with the others. So you connect the all clock pulse of these D shift register together and actually call that CK or CP clock pulse. Okay. So similar with actually the other design that we had for shift register. So just let's see what we want to do. Okay, so whatever we have here, so which is this one, right? So what it should be moved whenever you see the rising edge should be actually moved to here. So that means the output of this should be input of this one. So that means see the output of this should be the input of this one. So the similar things, whatever you have here as an output should be goes to the left. So that means I need to connect this to the input of this. So whatever you have here should be connect to this. And you tell me where we need to connect this. So whatever you have here should be rotate, right? That means the output of this flip-flop should be the input of this. So that means you should have something like this. Its output goes to the input of this. Okay. So definitely you could label them. So you could say this, whatever you have here is Y3. So whatever you have here, you label that Y2. So whatever is here is Y1, and definitely this one is Y0. Right, so this is Y0, this is Y1, this is Y2, this is Y3. Okay, so we are not done. So as you already remember from our previous design. So each D flip-flop has actually two other pins. One is the preset, one is the actually clear. So let's to see what we should do with these pins. So we have clear, we have preset. So similar with the others, so we are connect the old preset. So what is the preset and clear? If you active that, which is based off this circle that you see here, they're active with the 0. They should be actually make the output set, which is 1. And if you active this clear, it's actually put the output 0. Okay. So that means whenever you active these two, no matter what you have in D and F, you could set and you could reset. But whenever they are deactive, which is you could deactive with 1, the flip-flop actually do its normal job. So we don't need to actually these preset. So we actually connect all of them and connect them to the VCC or 1. So that means all of them is deactive. But for clear, so we actually connect all these clear that we have here. Actually connect all of them and label that as an initial. What the initial pins means, this is somehow is the reset. So that means before you start to work with these registers, just for a short time, you active this. That means all condition is 0. Then it's actually back to the 1. So that means this one is deactive too. Then the shift register do its own job. Okay. So it should be able to do what we want. So if this is your clock pulse, and if it is sensitive to the rising age, which is you have one rising age here, rising age whenever it's moved from 0 to 1, right? So that means whenever you see the first rising age, so this is what happened in the first rising age. So whatever you have here, move to these y0, whatever you had in y0, move to y1, whatever you had in y1, move to y2, and whatever you had in y2, move to the y3. Okay. So same thing. So this is just one bit. So then in the next actually rising age, the same story. Whatever you have here comes here, this goes here, this goes here, and this one actually back to the beginning. So we could actually simulate this and make sure it's actually we had a right design. So let's check the simulation and see what we have here. So let's see if we could minimize this. It should be fine. Just to make that a little more. Okay. So this is actually the same circuit. So you have actually the D. So this is 1, 2, 3, 4D. So just check the whole design that we had. So start with the clock pulse. So these are the clock pulse, all clock connected to each other and connected to the actually the function generator, which is produce this square wave with actually to change the frequency to the hertz. And I don't know which value we put, 0.5. Okay. So that's actually frequency 0.5 hertz. So check the input. So as I already mentioned, so see whatever you have here, the output of this connected to the input of this. So the output of this is connected to this input. Whatever you have here is connected to this, and the output of this, it is actually back to these input that you see you have here. So same thing for clear. So the all CLR, which is the clear, is connected to each other and then connected to the one switch, which we able to reset that just for a short time, just put the 0 and back to 1. So the preset in our design all connected to the 1, which should be deactive, this connected to the 1, this connected to the 1. The only difference here, I didn't connect this preset of this to the 1, just I connect these to the switch. There is a reason for that, because whenever you initialize this, you reset everything is 0. Okay, so then if they shift left and rotate 0, we couldn't see any LEDs here. We need at least to preset one of them and make them 1 for a short time, then they'll be able to see how that 1 actually shift to the left and also rotate. Okay, that's what I have this. I just make this for a short time, 0, make 1, 1, that immediately actually back that to the 1, which is deactive that. So that means I put the 1 here, then I will be able to see how this 1 is shift left with rotation. So let's do that. Let's actually start the simulation. So see, in the beginning, I just active the initialize, so just for the short time. The short time 0, 1, so everything is 0, right? So this is actually shift left with rotation, but because everything is 0 here, we couldn't see anything. So let's just make a 1 here, then, so I put that 0, make a 1 and back to the 1. Then you could see this shift actually left, then should be rotate back to here. So you have here, should be go there, should be here, should be in the next actually rising edge here, in the next it is here, okay? So as you could see, it's actually do that, okay? So again, back to here as a rotation. So see, it is actually it works, the design works, and it is the shift left with rotation.